Hello ladies and gentlemen, this is Abdul Rasul and the corresponding author is Professor Xiang, and the topic is a novel word embedding method for the real-time sentiment with integrated LSTM and CNN model. The agenda is first abstract, introduction, preliminary and the method, then experiment and result, and lastly conclusion. So what is the problem statement? Machine learning actually is facing some accuracy problem, and deep learning is providing that solution, but it's still based on a spec based extraction that reduces the individual word accuracy in real time. So solution, we provide a word embedding method for the real-time sentiment by proposing a new word embedding method. Its name is word-to-word graph, W2WG. The method is assemble different kind of lexicon dictionary and then imply the W2WG word embedding and then integrate with the LSTM for the feature for the sentiment classification. We used two kind of data set, the tutor and the IMDb data set. First of all, introduction. Recently, the text data is becoming massive because of internet explosion. For example, the Twitter user in one day is just 5 million tweets per one day is going to be online. User emotions and opinions is very important for industries, and we can get that emotions by using the NLP and sentiment. And in a couple of decades, last decades, the machine learning has been adopted, but still it's leading the low accuracy with the different domains. So to overcome these issues, word embedding method has been adopted, and in this paper we have three major contributions. For example, first is the proposed of word embedding, word-to-word graph embedding method for the real-time sentiment, and the two popular neural network LSTM and CNN has been integrated for the sentiment analysis, and the dataset is IMDb, and the tutor data has been used to validate the effectiveness of the proposed method. So here is some preliminaries. First of all, we take the three different kind of lexicon dictionaries and we assemble them, and the second is word embedding. We used the basic word embedding as a preliminary, which is word to vector. And the next is the LSTM. It has a different kind of gates like input, output, or forget, or hidden layers. So we apply that for the word representation in a sequence data from the time series. And the next is CNN. Is also has four different layers: input and conventional and max pooling and fully connected layer. So these have been used for the text classification in our paper. So what is the method here? We proposed 6 different steps of our method. First is like we need to collect the data and process, assemble of lexicon and word embedding method, compute cosine distance, and then integration of deep learning models, and then evaluation. So first step, like acquisition of data and pre-processing, we take the benchmark data IMDb and the tweet data which contains on December 2020 the English tweets based on the COVID-19 data. Then assembling of lexicon dictionary, we use 3 different kind of dictionaries: SentiWord by using a positive score and negative, and the second sentiment 140 with the positive plus 1 as a positive and negative 1 is a negative. So the third dictionary is SentiNet4 is assigned the score in the range of -1 to +1, and then we apply the cosine distance because of similarity, word similarity, and lastly is a integration of that deep learning model to find the text representation, and lastly eventually like these 3 matrices, precision, recall, and F-measure have been used to evaluate the performance of our proposed model. The main important step is word-to-word graph embedding, which is a key contribution of this paper. This is the simple equation of word graph. like the W is a vector and E edges, and the next is we propose the different equations from the Kullback-Leibler divergence, and here we achieve the low dimension vector between two words, assigning the equal values in both words and co-occurrence by joint probability to get the word embedding vectors. So here we propose an algorithm, word-to-word graph embedding. First, it will take the words as a graph, and second, vocabulary of word from the dictionary will be assembled, and then co-occurrence will be computed by the cosine distance. So here we have the sample edge of one word. It will be compared with the k values, and if the sample is going negative with word I to wi, our sample will go negative word with wi to wj, then it will update the word vector, and this will process our the word embedding for word-to-word graph. So next is data descriptions. We crawl the data, and it has 1 million tweets. After pre-processing, it's just 6227. So this is the data, and then positive and negative classification based on the sentiment. And implementation is W to WG embedding applies on both data set individually. The integrated LSTM-CNN model with convolution and max pooling layer for the sentiment classification. Similarly, some baseline methods, for instance SVM with polynomial kernel and multinomial neighbors, have been compared. So experimental results, sorry for this, and experiments and results. Here first we provide the results of our method WRS with the tutor data set with 5 different types. For instance, like SVM and then V and the W to word vector, the basic one, and then integration of the individual LSTM and CNN, and lastly we integrate both models, and we find the F score which is highest than before, and then there is a execution time, like how much time it will take. We can see its execution time is somehow more than the previous one. For example, the CNN, it has just 97 seconds, but it is more. But as compared to the execution time, the F score, the accuracy is better than the Oz model. And the next result is performance evaluation based on the IMDb data set. Here is same system like with the 2 machine learning based model and the word embedding method and 2 deep learning method. And lastly is the integration of both deep learning model. And here we can see the performance is 0.89, and the rest of the others, precision or recall and FMIR, all of them are a little bit less. Here we provide the comparison of our result of our method with remaining and with existing studies. For example, here it uses also word-to-vector, but we used word-to-vector, but our word-to-vector is based on word-to-word graph embedding, and it's just a simple word-to-word vector. It is applied on IMDb data. We also apply MDPI data, and we got 89.8 accuracy, but it has 77.11 accuracy. And the same as like Mr. Hong, it apply on LSTM with the same data as we have did, and its integration with CNN as we did before, and it's here has 87.8 accuracy. So in all comparison, we have the better accuracies as compared to some existing work. And here the conclusion is, recently AI, artificial intelligence, achieved a tremendous boost in real-time computing for the text classification with NLP. Traditionally, machine learning techniques provide the limited accuracy with the lexicon dictionary for real-time sentiment. So here we propose word-to-word graph embedding as a pre-execution step for our proposed method WRS, and this method applied on MDB and two dataset. And this method proposed word embedding and integration of LSTM-CNN performance outperformed the other technique and recently available studies for the real-time sentiment classification. And the future aspect to the evolution will be the different real-time data set and the neural network to experiment on the context-based sentiment. And there are some references which we used in this PPT, but in paper there are more than these. And thank you so much for listening. Have a good day.